You know that feeling, right? You've got a device you rely on, and then one day, it just dies. Maybe you hear a little pop, maybe you smell something weird, and that's it. It's done. Well, a lot of the time, the culprit is this tiny little component that most of us never even think about. Today, we're going to pull back the curtain and find out why these little cylinders, capacitors, sometimes go out with such a bang.
So, let's just get right into it. If you've ever looked at a circuit board and seen one of these things with a bulging, puffed-up top, that's not just a little cosmetic flaw. Oh no, that's a warning sign. It's basically a tiny bomb counting down, and understanding what's going on is really the key to saving your gear from a sudden smoky end.
And that's exactly what we're going to cover here. By the end of this, you'll have the knowledge you need to spot the danger signs, to understand the really common mistakes that cause these things to fail, and, most importantly, how to stop it from happening to you.
Okay, so let's start at the beginning. What in the world is this little component, and why is its failure such a massive problem for pretty much all of our gadgets?
The best way to think of a capacitor is like a tiny but incredibly fast battery. Its whole job is to store up a little bit of energy and then release it in an instant. It acts like a shock absorber for electricity, smoothing out the power, protecting all the sensitive chips from spikes. It's what keeps your phone, your computer, your TV, all of it running stably. So you can imagine when it fails, that protection is just gone.
Now, here's the thing. These components don't just blow up at random. Nope. There are very specific reasons they fail. So let's break down the 4 main culprits, the 4 roads to failure.
It really all boils down to just a few things. Too much stress, too much heat, old age, and, well, one very, very common human error.
First up is overvoltage. See, every single capacitor has a voltage rating. It's the absolute maximum it can safely handle. If the circuit sends more voltage than that, even for a split second, it's like overinflating a tire. The insides start to break down, and failure isn't just possible, it's pretty much guaranteed.
The second big one, and this is a real silent killer, is heat. All electronics create heat, right? But if that heat can't escape, it starts to cook the components. For a capacitor, high temperatures will literally degrade the liquid electrolyte inside, weakening it from the inside out until it just gives up.
Third on our list is something that's just unavoidable: good old aging. Like anything else, capacitors have a limited lifespan. Over years and years of use, the electrolyte can just dry out. And this is especially true for the cheaper, lower quality ones. Eventually, they just wear out.
And finally, we have a classic mistake: reverse polarity. A lot of these capacitors have a positive and a negative leg, and you have to install them the right way. If you put one in backward, well, it's like trying to make it breathe backward. You get a super fast, destructive chemical reaction. It's a surefire way to get a pop and a little puff of magic smoke.
And here is a perfect, real-world example of that overvoltage problem. Let's say a TV circuit board needs 12 volts, but to save a few pennies, a manufacturer uses a capacitor that's only rated for 10 volts. Well, that component is now living on borrowed time. It's constantly being stressed beyond its design limits, which is what leads to that puffed top, the leaking gunk, and eventually, a dead capacitor. Those ratings are the law, not a friendly suggestion.
Okay, so we know why they fail, but how do you spot one that's about to fail? The good news is, your devices have a sort of silent alarm system. You just have to know what to look for, and what to smell and listen for.
And it really comes down to a simple diagnosis using 3 of your senses. First, you're going to use your eyes and just look for any physical signs of distress. Second, you're going to use your nose, because a failing capacitor often lets off a very distinct smell. And third, you're going to listen to how your device is behaving, because that's often the very first clue something is wrong on the inside.
And here's exactly what to watch out for. Look for that little bulge, either on the metal top or the rubber bottom. That's gas building up inside from that chemical reaction we talked about. Check for any kind of brown, crusty stuff. That's the electrolyte leaking out. Then there's the smell. If you sniff something sharp, kind of like vinegar, that's a huge red flag. And finally, just pay attention to weird behavior, like a flickering screen or a device that keeps rebooting on its own. These are all cries for help from your hardware.
All right, you can spot the problem now. But how do you prevent it from ever happening to begin with? This is where you get to be proactive. And trust me, it can save you a ton of money and headaches. So here's your prevention checklist.
So how do we stop this disaster? First, when you're replacing one, always pick a capacitor with a voltage rating that's a little bit higher than what the circuit actually needs. That gives you a critical safety margin. Second, keep your electronics cool. Make sure they have good airflow. Heat is a major enemy. Third, don't cheap out. I know it's tempting, but spending a tiny bit more on a quality part from a good brand will pay off. Fourth, if you're doing a repair, please double, triple check the polarity before you solder. That little stripe on the side is not decoration. And finally, if you see any of those warning signs we just covered, don't wait. Replace that capacitor right away.
You know, the crucial takeaway here isn't really just about electronics. It's a lesson that applies to so many things. Capacitors don't just fail out of the blue. They fail because of small shortcuts, because of tiny warnings that get ignored, because of a little lack of attention to detail. And it's those little oversights that add up over time and turn into a complete disaster.
So, that really just leaves us with one final question. Now that you know the signs, you know the causes, are you going to be proactive? Are you going to keep an eye out for those silent dangers that might be lurking inside your devices? Or are you just going to cross your fingers and wait for the pop? The choice is yours.